Google Compute Engine lets you run Windows virtual machines on Google's global infrastructure. Let's learn more about starting and running Windows VMs in GCE. We'll also discuss managing Windows deployments.
In this module, we'll look at how to get up and running with Microsoft Windows Server and SQL Server on Google Cloud Platform using Google Compute Engine. Let's get started by looking at Google Compute Engine fundamentals. Google Compute Engine is the infrastructure as a service product on Google Cloud Platform. In this section, we'll look at the main features of the product and identify advantages of Compute Engine as a key foundation for your Windows workloads. When you get started with Google Compute Engine, you'll notice how easy it is to provision a virtual machine with the perfect configuration to suit your needs. You'll be able to select up to 64 virtual CPUs per machine with between 0.9 and 6.5 gigabytes of memory per CPU. You'll have the choice of standard and SSD persistent disks and local SSDs. You'll be able to get up and running quickly with available Windows Server images and Linux images. While you might be surprised to see Linux images in a class about running Windows workloads on GCP, later on you'll see how you can take your existing C# and .NET skills and apply them to code applications that run on Linux. Here's how you'll create a Compute Engine virtual machine with the Cloud Console web browser user interface. You should enter a suitable name for the VM and set the appropriate zone, which will determine the Google Data Center where the machine will be created. Also, you can see the machine type. This shows 2 virtual CPUs and 7.5 gigabytes of memory, and the 50 gigabyte boot disk with a Windows Server 2016 image. There are lots of other configuration options, but this shows all the basic choices that you'll need to make. Once your machines are configured, you'll connect them to each other using the Google Virtual Private Cloud Network resource. You'll automatically benefit from Google's extremely high performance network, meaning that you get 2 gigabits per second of bandwidth per core between machines running in the same zone, with an upper limit of 16 gigabits per second of bandwidth. In addition, when you provision resources in different Google regions, traffic between them will flow exclusively over Google's own fiber network, resulting in lower latency and higher throughput than if the traffic was routed via the public internet. To protect your virtual machines, there's a powerful, flexible, yet simple to configure firewall. You'll be able to make your Google resources available as a seamless extension of your on-premises environment using Google's virtual private network. Finally, we'll see later that Google's infrastructure will enable you to run your application with high availability and scalability taken care of with an HTTP and HTTPS load balancer or the TCP and UDP load balancer. At the time this slide was presented, Google's Windows Server images include Windows Server 2008 R2 Desktop, and 2012 R2, and 2016 with both desktop and core versions. The price for the virtual machines provisioned on Google Compute Engine includes the Windows Server license. This costs 4 cents per core per hour. This is prorated per minute, with a minimum of 10 minutes, just like Compute Engine's own hardware billing. Next, let's look at Microsoft SQL Server support. Google supplies pre-configured Compute Engine images for the Express, Web, Standard and Enterprise editions, with 2012, 2014 and 2016 versions available for all except Express. Each SQL Server edition can be deployed on a variety of versions of Windows Server. Take a look at the docs for more information on this. Once again, the default price includes both the Microsoft Windows Server and SQL Server license cost, with the same per-minute billing. However, in this case, you'll be able to bring your own license. If you need pre-configured Windows infrastructure that's ready to go, then you'll want to look at Google Cloud Launcher. This example shows the ASP.NET Framework solution that comes with pre-installed Internet Information Services and ASP.NET. There's also a high availability SQL Server solution, which will install multiple servers and configure the network to enable SQL Server always-on availability groups. We'll take a look at that later in this module. Once your virtual machines are up and running, you'll want to connect them to perform general systems operations tasks, such as installing and configuring Windows features in your own applications. You'll be able to connect using Remote Desktop Protocol, and you can even do this without leaving your browser by installing the Chrome RDP for Google Cloud Platform extension. Of course, you can also use Microsoft's RDP client instead. It's common to configure your Google Compute Engine Windows virtual machines using startup scripts. Startup scripts can either run once on the first boot in system preparation or on every boot, and can be written as batch, command, or PowerShell scripts. This example shows a PowerShell script that could be used to automate connecting a Windows Compute Engine instance to an Active Directory domain. Google Compute Engine offers very high-quality infrastructure. It also offers extremely cost-effective infrastructure. Here are 4 ways to save money on virtual machines. First, we've mentioned already that Google Compute Engine VMs are billed per minute rather than per hour. Second, while there are a wide range of pre-configured virtual machines with up to 64 cores and 204 GB of RAM, it's possible to select the perfect number of cores, divisible by 2, and perfect amount of memory between 0.9 GB and 6.5 GB of RAM per core. For example, you can select a virtual machine with 18 cores and 36 GB of RAM if that's the best fit for your workload. Third, if you use standard VMs for a sustained period, you'll benefit from lower per-minute costs. For example, if you run a machine for a complete month, then the per-minute cost of that virtual machine will be 30% cheaper than the standard per-minute charge. Fourth, if you have workloads that can tolerate interruption, such as rendering frames of video, you can run preemptible instances at 80% lower per-minute cost than standard. These machines have a maximum lifetime of 24 hours, but may be preempted by Google if the resources they consume are needed to run other work.